Hi there. Let's talk about electrolytic cells. So we've done galvanic cells together already, if you've watched that video. So the first thing I want to do is compare galvanic cells to electrolytic cells so you can tell the difference. Now, the first thing you'll see is that galvanic cells actually have two half cells, two separate places where you have different electrolytes, whereas electrolytic cells all happen in one big cell. Right. The similarity is that both of them have electrodes, right? So the anode and the cathode are defined by what redox reaction occurs there. So an easy way to remember that oxidation happens at the anode is anox. And reduction always happens at the cathode, so that is redcat. Easy. Right, so in a galvanic cell, the energy conversion is from chemical potential energy to electrical energy, right? So in a galvanic cell, we have spontaneous reactions and we get electrical energy from that. In electrolytic cells, we have electrical energy that is converted to chemical potential energy, right? So in order for electrolytic cells to work, we need to add energy to it. So we usually use lots and lots of electricity to get our electrolytic cells to do what we want them to do. So that means they have non-spontaneous redox reactions happening inside them. Right. What's similar to both of them is they both have electrolytes. Now again, an electrolyte is a liquid that has ions in them. So ions, they're positively and negatively charged particles, and this allows charge to move through the liquid. Then, what makes galvanic cells a little bit more unique is that they have salt bridges, whereas electrolytic cells do not have salt bridges. Right. Also, electrolytic cells are usually really big because we use them in industry and they might look something like this. Whereas galvanic cells are usually quite small and they fit in things like a torch or a phone battery or something like that. So let's have a closer look at an electrolytic cell. So in this electrolytic cell, we've got a copper chloride solution that is in our cell. And in this solution, because it's in an aqueous solution, it splits into positive copper ions and negative chlorine ions. So we have ions in that solution. So let's see what happens here. So the chlorine, the negatives from the chlorine, is attracted to the positive electrode there. And they deposit their surplus electrons on the electrode. And so the chlorine negatives turn into Cl2 positive, which is a gas, and those bubble and leave the cell. Right. Then those electrons that the chlorines lost, so the chlorines lost electrons, so they underwent oxidation, right, which means that this is the anode, right? So the chlorines lost those electrons, those get drawn up to the positive terminal of the battery. Then at the negative terminal of the battery, we get electrons that are produced, and those go towards this electrode here. Now, that electrode attracts the copper ions that are in the solution. So those go onto the electrode and join with those surplus electrons, and that forms copper solid. So what's happening here is we're getting gas at this one electrode, and at the other electrode we're having a coating of copper that's forming on it. Now these are two carbon electrodes, so those don't participate in the reaction, they just allow electricity to be conducted through the circuit. Right, so we call this decomposition process, where we break things up, electrolysis. So we're using electricity to break things up. And now I'd like to show you a little experiment which is literally exactly the same as what we just looked at. So what you're seeing in front of you is almost an electrolytic cell. The only thing it's missing is its other electrode. So that is a carbon electrode that is attached to the positive terminal of a battery. That liquid is our electrolyte, and that is copper chloride. So in that solution, there are copper positive ions and Cl negative ions, exactly the same as the diagram you saw just before this. So what I'm going to do is I'm going to place a paperclip into the solution that is attached to the negative terminal of my battery. And hopefully we're going to see copper ions undergo reduction and form solid copper on the paperclip. So what you're seeing there is a discoloration of the paperclip, and that is the brownish copper that is forming on what is now our cathode. You're also seeing bubbles that is forming around the anode, and that is chlorine gas from chlorine ions that was undergoing oxidation, i.e. losing its electrons in order to form chlorine gas. I hope that shows you just how interesting science can be. So those were electrolytic cells in a nutshell.